Hello there and welcome back to the channel. I don't know if you've been watching my recent series of videos about my astrophotography trip to Namibia this summer, or if you just want to watch this because you're interested in LRGB processing. Either way, I got some great data on that trip on the Corona Australis Molecular Cloud, and in this video I'm going to be processing that LRGB data in PixInsight. Hopefully you'll find it a useful and informative video. So let's get started. Okay, so let's start by having a look at the data that I acquired. So I'm here in PixInsight in the weighted batch pre-processing script on the calibration tab, and you can see that I've already loaded in all of my different files. So let's start with the lights. I've got 70 frames of 180 seconds on the luminance, 14 of 180 seconds on the red, 13 of 180 seconds on the green, and 12 of 180 seconds on the blue. Didn't quite manage an equal number in all, but that's what I managed to come home with. I also took flats, so I've got 15 flats on each of the filters, all with slightly different exposure times just to try and get a similar histogram, those are all nice flats. And then for my darks, I've got 15 darks of 180 seconds for the light frames, and then I've got 20 darks of 3.1 seconds, which is for the flat frames, and I haven't used any bias frames at all. So that's the weighted batch pre-processing setup. I've actually already run that and produced the output, so I'll close the dialog, and the output from that is here. So we've got the luminance, which I'll just do a screen stretch on. So there's my luminance, and similarly I've got red, green and blue. Now I've actually already run Blur Exterminator on all four of those, so that's where I'm going to pick up, and the next step is to combine red, green and blue using channel combination. So I've already set up the dialog here to combine my red blur exterminated, green blur exterminated and blue blur exterminated image. So I'll run that now, and that produces my colour image. Now this, remember, I'm only going to use for the stars and for the colour of the nebula, but not for the brightness. I'll use the luminance for the brightness of the nebula. So what I need to do first on this here is get the colours right. You can see it's very green. In order to get the colours right, I'm going to run a script image analysis image solver, so essentially plate solving this image so it has an astrometric solution. And then once I've done that, I'm going to run a spectrophotometric colour calibration to get the colours right. So I'll come back in just a moment when I've run the image plate solver script. Okay, so the plate solve was successful. So the next thing I'm going to do is run the spectrophotometric colour calibration. I set up the QE curve to include the Sony 571 sensor, which is what I have in my ASI 2600mm Pro, and I've set the red, green and blue filters to BARDA R, BARDA G and BARDA B, as those are the filters that I use. So I can now apply the spectrophotometric colour calibration. I would apply a region of interest, so let's just do that. We'll basically just pick up on a small area of image as a region of interest, and I can now drag that preview over the region of interest here. There we go, and now remove the preview and let's set it going. Okay, that's finished. I can see I've got some nice response plots on this output screen from the SPCC process. I can close that now, and you can see that the green hue has disappeared and our colours are looking really very nice. So that is the colour correction on the RGB stars. So the next thing I'm going to do is to bring up Star Exterminator, and I'm going to run this on the RGB image, except I'm going to make sure I've got the generate star image ticked and the unscreen stars ticked as well. That's because when I bring the stars back into the final image, I'm going to screen them in, so they need to be unscreened at the Star Exterminator step. I'm also going to use large overlap. It does make the Star Exterminator take a bit longer, but it gives a slightly better result, so I prefer to wait the extra time and get the best result I can. So we'll set that running, and I will be back in just a moment when that's complete. Okay, so I've now got an RGB stars and an RGB image. So you can see here it's my star exterminated image. I can now see the colours that I'm going to be applying to the nebula, and here is my RGB stars image. It has got an auto stretch on it, so it looks a bit odd. If I remove the auto stretch, you can basically see that it's basically just my stars. Okay, so I'm actually going to save this file and the other one to disk, and I'm going to put them to one side, and the next thing I'm going to do is process my luminance. So let's just very quickly do a file save as the RGB, so it's an XIF file, so it's an RGB starless. (32-bit). And also going to save my unstretched stars image as well. File save as, and that's RGB stars. Save. I have run these steps before, which is why it's seeing that the file already exists, but no issue there. Okay, great. So as I say, I'll put those to one side. I'm now going to work with the luminance. So let's just put these down here, and let's bring up our luminance image. Remember, this is still a linear luminance image, and it's been blur exterminated. So what I want to do to this now is to remove the stars from it. So we'll bring star exterminator back in. This time we don't want to generate a star image, but I'm again going to use large overlap to get as good a result as I can. So I'll set that going. Okay, so star exterminator is complete. Let's just do a screen stretch and have a look at what we've got. So we've got some very nice luminance data here. You can see a little bit of noise in it. So I think what I would like to do next is to run noise exterminator on that. So we'll bring up noise exterminator. And it's very much something to experiment with. If you want to experiment, it's a good idea to pick a small portion of image as a preview, select your preview window, and then bring up a preview, and then it can produce your preview pretty quickly. Just takes it a few seconds each time, and you can now adjust your slider. So for example, with no denoise at all, it would look like this, and with maximum denoise it would look like that. So you can pick your compromise, how much denoise and how much detail. So you can maybe go to 0.75 on the denoise, for example, 0.6 on the detail. That doesn't look too bad. Once you're happy with that, you can close the preview. Actually, just switch off the preview and then delete the preview and back to the full image, and then you can apply it. Okay, so I've now denoised my luminance, and I've actually just changed the identifier on it to just record that it's a luminance with blur exterminator, star exterminator and noise exterminator. So I'm now just going to put that to one side for a moment and bring up the RGB starless, which I haven't yet denoised. So I'm going to apply the same denoise. Remember, this again is a linear image, it's not actually non-linear stretched yet. And I'm going to apply the same noise exterminator settings to the RGB starless that I just did to the luminance. Okay, so I've done the noise extermination on the RGB starless. Now what I want to do is apply my non-linear stretch both to this image and to the luminance image. So I'm going to use generalized hyperbolic stretch to do this, and in particular I need to pay special attention to this bright core here. Without a stretch, you can see that the center of that bright area is already clipped significantly, and I don't want to make that, certainly don't want to make that any worse. So I need to be able to raise these faint areas without blowing out that core. So we'll take off the screen stretch, bring up a preview, and I'll start by zooming in on the histogram and putting a symmetry point just to the left of the peak of the histogram. So I've clicked on that and I hit send to SP to set the symmetry point, and now I can apply my stretch factor, and I'll just zoom out so you can see the stretch happening. And I'm just looking not to do the full stretch here, but to lift up the faint areas enough to be able to see those details. And the core will appear to blow out here, but that's not something I'm too worried about initially. So I just want to be able to see those faint details, and now I can lift the local intensity in order to stop that core from blowing out. So just to demonstrate that, if I just zoom in on this area here, you can see that the stretch has blown out that area, but that when I raise local intensity, it recovers the situation. So that's really important to see that we've lifted up these faint areas without blowing out the core. So I'm happy with that as the first stretch, so I'm going to apply it and then reset my stretch. So now I'm going to do a second stretch. Now what I want to do is pick the sort of mid-range of these faint areas here. So somewhere like here, for example, I'll click there in the image and set that as a symmetry point. So now when I apply a stretch, it will stretch around that symmetry point and increase the contrast in the image. That's looking nice and it's really bringing out the colours that I'm after. But again, the core is clipped, so I'm going to raise that local intensity to prevent the core from clipping, and if necessary I'll back off on my stretch a little. I'm just going to check again with a quick zoom in on the core and see if that is clipped too much. I can also have a go with protect highlights here. That's another way of protecting that, and that's actually worked pretty well. So I can go back now to my image, and I'm happy that for the colours that this is going to do what I want. So I'm going to apply that, and that's now my RGB colours, and we can close down the preview, and there's the RGB colours. So now what I want to do is do my stretch on the luminance, remembering this, the screen stretch looks like this. I'll take the screen stretch off and turn on the preview, and we'll do the same sort of process. So I'll hit plus, I will find where the histogram lies and set a symmetry point just to the left of the peak, zoom out, do my stretch. Again, same objective as before, I want to be able to see those faint areas in the nebula. Okay, something like that. And then I raise the local intensity to resolve the clipping of the core. And that's a reasonable first stretch, which I will now apply. And we reset the stretch. Okay, and so for our second stretch, we pick the place we want to stretch around. Something mid-range, maybe here. Send that to the symmetry point. Now apply the stretch. And I'll just increase again the local intensity to resolve issues with the core. I'm going to zoom in on the core, just preview the core again. It's a little bit too much, so I'm going to pull down the protect highlight slider to recover that a little. Go back to the full preview, and it's just the black level now that I'm not too happy with, so I'm going to apply that, reset my stretch and switch to linear, and now I can bring up the black level, raise the black level to make that background darker. Okay, and I'm pretty happy with that, I think, so I will apply that. And reset. Okay, so here's my stretched luminance, and here's my stretched RGB. So what I want to do now is combine them together to produce an LRGB starless image. And the way that I do this is I take the RGB image and use the channel extraction tool to extract the red, green and blue from the RGB image into 3 separate grayscale images. Then I will have a luminance, a red, a green and a blue, and then I can use LRGB combination to combine all of them. So this will take a few seconds to produce a red, green and the blue image. There we go. And now I can bring up LRGB combination, and I think actually all the file names in there are already correct. Let me just check, and I can apply that. So it's quite a quick process. It's almost finished, and we should get our LRGB starless image. As soon as I've got that, I'll close these separate red, green and blue images. There's no need to keep those. We'll shut those three down. And here is my LRGB starless image, which is looking really nice. Happy with that. And now I want to add in the stars. So here's my RGB stars image, and I need to apply a stretch to that as well. So I'll bring up generalized hyperbolic stretch, but I'm going to use the arcsine H algorithm. Always use that one on stars, seems to give the best results. So I can now apply my stretch, and what I'm looking for is to bring out in particular things like this globular cluster up the top here. I don't want to bloat or blow out too many stars, and I don't want my stars to be so bright that they detract from the nebula. So something like about that I'm happy with. I can apply that, close the preview, and there's my stars image. So I can now use Pixel Math to combine my LRGB starless image with my stars image. So here's the algorithm I use for screening in the stars. I'm just going to change the name of the LRGB starless to starless LRGB, and now within Pixel Math I've got a create new image and color space is set to RGB color. I can now apply that. And now we have the final image, LRGB with stars. And I'm pretty happy with this. It's still something that I would probably carry on tweaking. I might even take it into Photoshop and have a go at adjusting maybe the color saturation, which of course I can do here as well. Maybe the clarity, maybe the black level, just to finalize that image. But that's pretty much the basis of a final image, even if it's not the absolute finished product. I hope you found that useful. That's how I process LRGB data, and I hope that you come back next time for my next tutorial. Take care and clear skies.